Right now, without trying, you're reading. You aren't identifying individual letters. You aren't decoding syntax or assembling shapes into sounds. These marks on a screen become ideas inside your head, instantly, without friction. Now try something different. Calculate the exact number of hours you've spent awake over the last 3 years. The gears grind, your mind slows down, works step by step, and hits a wall. Same brain, same hardware. Why is one task effortless and the other agonizing? Most people land on the same answer: speed. We think of intelligence as a high-performance engine. The faster it runs, the smarter the output. If our brains could just process information as fast as our senses receive it, we'd all become effortless geniuses. It's an intuitive assumption. It's also wrong. And the proof is sitting on a chessboard.
Watch a chess grandmaster analyze a position. Within 3 seconds, they play a move that secures a winning advantage. To an outside observer, it looks like their brain is running through thousands of variations per second, a biological supercomputer. For decades, cognitive psychologists assumed exactly that. Expertise was brute force speed. In the 1940s, a Dutch psychologist named Adrian de Groot tested this. He recorded the thought processes of world-class grandmasters and strong amateurs as they worked through complex positions. If speed was the answer, grandmasters should have been evaluating vastly more moves, searching far deeper into the tree of possibilities. They weren't. Both groups calculated roughly the same number of variations, but grandmasters found winning moves in seconds. Amateurs spent minutes wandering down dead ends. So if it wasn't speed, what was it? 30 years later, Chase and Simon ran an elegant experiment. They showed players a board position for 5 seconds, cleared the pieces, and asked them to reconstruct it from memory. Real tournament positions. Grandmasters placed 20 out of 25 pieces correctly. Amateurs managed fewer than 6. Then they randomized the pieces, positions that could never occur in a real game. The grandmaster advantage vanished entirely. They were never computing faster. They were recognizing structured patterns, what cognitive scientists call chunking, the same way you read the word chess as one concept instead of 5 separate letters. A grandmaster reads a cluster of pieces as a single tactical unit. They weren't thinking faster. They were thinking differently. This reveals something fundamental about computation, something that goes far beyond chess. Multiply these two numbers. Painful. Roman numerals offer no positional alignment, no place value system, no clean algorithm to follow. Now, the same problem. 36. Instant. The math didn't change. Your brain didn't get faster. What changed was the representation. Arabic numerals compress positional logic directly into the symbols themselves, reducing a multi-step calculation to a single memory lookup. This is what the speed assumption misses entirely. If a problem has billions of possible paths, doubling your clock speed doesn't make you a genius. It just lets you hit the same wall in half the time. The question isn't how fast your brain computes, it's how efficiently it represents the problem in the first place.
So if raw speed doesn't explain expertise, what does? What's 12 times 12? You didn't add 12 to itself 12 times just now. You retrieved the number 144 from memory, instantly, without effort. But there was a time, probably in 3rd grade, when that calculation was an active, painful task. You counted on your fingers, you made mistakes. Over time, your brain performed the work, compressed the result, and stored it. The next time you needed it, the computation had already been done. This is what practice actually is. Not training your brain to think faster in the moment, but shifting computational work backward in time. Every hour spent practicing an instrument, studying code, or memorizing chess patterns is computation invested ahead of time. When an expert acts effortlessly, they aren't computing in real time, they're deploying pre-computed results. Which raises the question we've been building toward. What happens when you encounter a problem so novel that no prior pattern exists? When the search space is too vast for any amount of practice to have mapped in advance? The brain has no choice. It drops back into live, real-time search.
And live search in a biological brain is slow. From the moment photons hit your retina to the moment your visual cortex registers a conscious image, roughly 80 to 100 milliseconds elapse. You are never experiencing the present moment as it happens. You are living a tenth of a second in the past. Yet your experience of the world doesn't feel delayed. Everything feels seamless, simultaneous, immediate. That seamlessness is an illusion. Your brain creates it through temporal buffering. Physical signals travel at different speeds through your body. Light reaches your eye almost instantly. Sound takes longer. Touch from your foot takes longer still. Instead of letting the fast signals arrive first and creating a jumbled mess, your brain deliberately holds the fast signals back, waits for the slow ones to catch up, and stitches them all together into a synchronized experience of now. Neural delay isn't a defect, it's the stabilization mechanism that keeps perception coherent. So here's the question. If intelligence isn't about speed and these delays serve a critical purpose, what would actually happen if we removed them?
Let's make one impossible change. Modify human biology so neural transmission delay drops to 0. Electrical spikes cross synapses at the speed of light. Sensory signals reach the cortex unbuffered and unaligned. The first result is not elevated intelligence, it's perceptual collapse. Under normal conditions, your eyes perform tiny involuntary twitches called microsaccades, several per second. Your brain actively suppresses visual input during each twitch and fills in the gaps, smoothing your vision into a steady camera pan. Remove the neural delay, and that smoothing breaks. You perceive every raw, violent jitter of your own eyeballs. Vision becomes a chaotic strobe. Simultaneously, the world you've always taken for granted fractures. A ceramic mug slips off a counter. You see the impact instantly. Light travels at 300,000 kilometers per second, but the crash arrives later. Sound travels at 343 meters per second. And the vibration through the floor arrives later still. Nerve impulses propagate at 50 meters per second. Without the buffer stitching these inputs together, one event becomes 3 separate experiences staggered across time. You don't get a sharper picture of the world, you get a broken one.
But the disorientation is just the beginning. Biologists measure perceptual speed using something called critical flicker fusion, the rate at which a brain processes discrete visual frames before they blur into continuous motion. A human brain processes roughly 60 frames per second, a housefly 250. To a fly, your swatting hand approaches in lazy slow motion. It has enough subjective time to plot an escape, adjust its wings, and take off before your palm arrives. With 0 neural delay, your flicker fusion rate would climb past 1,000 frames per second. 1 clock second would stretch into minutes of internal experience. It sounds like a superpower, until you try to speak. Your mind is racing at 1,000 frames per second, but your vocal cords are made of muscle, tissue, and cartilage. They need 50 to 100 milliseconds to physically flex and vibrate against air resistance, an eternity at thought speed. Force them faster, and the friction would shred the tissue apart. So when a friend says hello, a word that takes about 300 milliseconds to pronounce, your accelerated mind experiences something very different. First, a 10-minute low rumble as their lips part. Then, a deep, booming sub-bass drag as the vocal cords vibrate. By the time they finish one word, you've lived through half an hour of solitary silence. Physical conversation becomes impossible. Every person around you becomes a frozen, motionless statue, whispering in frequencies too slow to follow. You have the fastest mind on earth, and no way to share a single thought with another human being. But even if you accepted the isolation, even if you could endure the frozen world, your accelerated mind faces one final wall. Right now, your senses absorb roughly 11 million bits of raw data every second. Your retina performs edge detection and discards 99.9% of incoming photons and sends a heavily filtered summary up the optic nerve. Your conscious mind receives about 50 bits per second. That extreme compression isn't a limitation, it's the mechanism that makes meaning possible. Think about a song. A song is not a list of 44,000 audio samples per second. A song is the emotional pattern that emerges when those values are compressed across time. Without that compression, there is no melody, only noise. Without your brain's predictive filters processing all 11 million bits raw, you no longer see a friend's face. You see millions of individual pores, flaking cells, pulsating capillaries. You no longer hear a voice, you hear air molecules slamming against your eardrum at discrete frequencies. You no longer feel a handshake, you feel microscopic friction patterns across individual nerve endings. By processing everything, you understand nothing. This is the domino that completes the chain. Faster processing doesn't just desynchronize your senses. It doesn't just freeze the world around you. It destroys meaning itself. Because meaning was never in the raw data. Meaning is what your brain creates by throwing most of the data away.
So we return to the hypothesis. If your brain could process information as fast as your senses receive it, you would become a genius. The domino chain says otherwise. Remove the delay, perception fragments. Accelerate processing. The world freezes while your body can't keep up. Remove the filters. Meaning dissolves into noise. Consciousness is not a live broadcast of reality. It is a delayed, heavily edited, radically compressed summary. And that compression is not a compromise. It is the entire mechanism by which raw physics becomes experience. The 100 millisecond delay is the price your brain pays to hold reality together. The 50-bit bottleneck is the filter that turns 11 million bits of chaos into a face, a voice, a song, a thought. And we've already built this trait ourselves, just not in biology. When a language model trains for weeks on millions of texts, it is doing exactly what your third-grade brain did with 12 times 12. Expensive work done once, cheap retrieval forever. The speed that feels like intelligence is pre-computation wearing a different mask.
The next time you're sitting across from someone and they pause mid-sentence, searching for a word, collecting a thought, and you feel that small flicker of impatience, remember what's happening in that pause. Their brain is holding raw sensory noise at bay. It is compressing a flood of information into something small enough to fit inside language. It is editing reality into meaning in real time on 20 watts of power. That pause isn't a failure of speed. It's the sound of a mind performing the most complex computation in the known universe. And it is the same computation happening inside you right now as you turn these words into understanding.